So my final video on initial thoughts about how h of x is affected by the values for a, b, and c. I'm going to look at h of x equals to the composite of f of x and g of x. So g of x is kind of embedded inside of f of x, and this is our function right here, if you can see. So it's right there. Yeah, so now I just want to look at the graph for this. And the way that I want to look at this graph, I just kind of want to compare it to both the sine graphs, the one in red, and the one for cosine. Um, and cosine is in green right here. I'm going to have to zoom in a little bit so you can see the difference between where the composite function h of x is and where cosine is, because they follow each other so closely. Um, they it's honestly almost the same. I'll zoom out. Yeah, so it looks um, like the composite function just looks like the cosine function, except the amplitude of it is a little bit smaller, just a little bit smaller than the amplitude of the cosine function. And I feel like this is happening because our cosine function was the one that went um, that's kind of the one that's deeply embedded into this. The sine function is like on the outside, and the cosine is on the inside. So I feel like of the composite, and I just feel like that has a lot to do with why this composite is following the cosine graph so closely. So I'll take off the sine graph. I just want to see how this composite function h of x behaves when a, b, and c are varied compared to how cosine is behaving, the graph of cosine. Oh, wow. Okay. Um, so it looks like it looks like the composite function graph at some point looks like it started happening probably around 2 is when it started, when a equals 2 is when it started kind of splitting off and doing a really weird thing where um, the the kind of waves that we're seeing in this graph, the blue, it's not it is not uniform. We're getting different sizes, and it's just getting weirder and weirder. Um, as we progress on this, on changing the value of a. Hmm. But it seems to be doing the same thing that the graphs of sine and cosine are, since they're symmetrical about the y-axis. It's not as much. There's not a lot of focus on the negatives or the positives um, versus the positives or anything. It's just what the number itself is, or the absolute value of the number, that's the main focus. So it it's multiplying more and more, it seems like. So seems like the higher that I go, like the higher value of a is, the more it seems to be like splitting off here. It's like it's doing cell division or something, which is really cool. But I wish I had a good explanation for this. I feel like maybe this is because this is a composite. Like, I kind of expected it to behave kind of weirdly. Um, so it's taking the sign of like a cosine function, and that's, I mean, I get it. I get why it's acting so weird. I'm just gonna take this cosine function off now. I just wanna, yeah, this looks like a heartbeat. Yeah, I just wanna zoom out a little just to see what is going on and when this seems to be kind of splitting off. Okay, so the first kind of split we have is at 2, and then these waves kind of just get deeper and deeper, and we have 4, and then at 5 they're splitting off again. Yeah, so it's just there's a lot happening, and it seems to be um, getting more and more kind of intense. And I can see, like, you can see that the amplitude is definitely changing. It is increasing just as it was with all the other graphs that we've looked at. It's just doing something weird at the top of this wavelength or of this graph, this curve. Just gonna take this back to 1. Um, we went on a wild journey there, but I'll see what happens when we vary B. This should be interesting. So, yeah, this is also doing a similar thing. It gets so small, like it looks like it's almost filling out. Like it looks shaded right here. It looks like I just made a ruler in Desmos or something. But that's how close together those different pieces of the close together the waves of the curves of the graph are. That's kind of amazing. Um, but if we just go back and examine, see things look pretty normal at 1, normal-ish. Um, and then at 2 again, just as with the value, the 2 was at A, it started splitting off and doing a weird thing. Um, yeah. And again, we have the absolute value factor where it doesn't, the sign of B doesn't necessarily matter, it's the value of it, the absolute value. And the higher the number seems to be, the more um, waves that we have per period or per cycle. Um, and I would like to do more work to figure out what exactly this means. Now I'm just curious to see if C is just going to remain the way that it has been for the past um, past graphs. I wonder if C is only going to horizontally shift this graph. Ooh, that looks like a jump rope. Okay, so I'm just gonna zoom out a little and see what's going on. Okay, so when I increase C, let's see when I decrease it. Oh, this looks really cool. I feel like if I just animate this, it's gonna have like an animation of waves. Maybe this is what they do on cartoons, or I don't know. Going on a tangent, but so yeah, it kind of at 7.6 right here, or like maybe 7, it kind of just bounces like above the x-axis, and then it comes back down, and then it goes back up again, and it seems to be staying in that range of 1 to 1. Maybe it's because our amplitude is 1 set over here. But I do not see any kind of horizontal shift happening. Maybe, mm, actually, I do see a little bit of a shift. Um, there's a shift happening as well as the there's like a vertical and a horizontal shift. It seems like um, it's actually really cool to play around with. Um, let's see. When I move from C to negatives, if this looks different, then moving towards the positives. Okay, so we have positives again. Okay, then negatives. Okay, so yeah, the waves, the curves, they seem to be, when we go towards the negatives, like we've been seeing, they seem to be shifting towards the positive. When C goes to negative, when C is a negative value, it um, graph kind of shifts towards the positive side of the axis. But when we increase it to positive values, it looks like it's moving to the left, meaning it's moving towards the negative side. So that's behaving like it's been for the past few graphs. It's just I want to figure out how to account for the little waves that are happening. This isn't like a uniform peak or that we're getting for our amplitude. It's like almost splitting off and then going molding back to just one curve, and then it's all just really, really interesting. So I would like to explore this a little bit more, but these are just my initial thoughts on all of this. I think I'm going to end that right here.